Let's talk about object pooling. This is our third and final tutorial to this mini-series. Check the description to get caught up. In Unity, we have specific methods that help us create and destroy objects, specifically the instantiate and destroy methods. They are useful and necessary methods during gameplay, and each generally requires minimal CPU time. However, for objects created during gameplay that have a short lifespan, such as our bullet holes, and get destroyed in vast numbers per second, the CPU needs to allocate considerably more time. Unity uses what's called garbage collection to deallocate memory that's no longer in use. Repeated calls to destroy frequently trigger this task, and this is the reason you'll experience a frame rate drop during the cleanup process of your bullets, especially on WebGL builds or mobile. Object pooling is the process of pre-instantiating all of your objects you'll need at any specific moment before gameplay begins. During loading, in awake, or void start is where you'd initialize your pool. You'd populate a set of bullet holes that can be used and recycle through that list. If we happen to run out, then we can dynamically create more at runtime. In this video, we're going to approach object pooling in the most simple to understand way using a list of objects and the setActive feature of Unity. This is a very simplistic approach, perfectly fine to be used in the industry and requires minimal setup. For a more modular approach, you can check out the Unity C# Survival Guide, which has more in-depth knowledge and implementation of creating modular object pools. Let's get started. I'm John with GameDevHQ, and we bring you amazing content 3 times a week dedicated to mastering game development. Smash the like button and give us a subscribe and join our community down below. Here we are in Unity where we left off, and currently what's happening is I can fire my Gatling gun, and we're basically creating a ton of bullet holes of varying kinds. So what we want to do is pre-instantiate these objects and add them to a list that we can recycle over and over again. We're also going to need to define a bullet hole behavior that's going to clean up our bullet holes by basically turning them back off so that we can reuse them within our list. So the first thing that we need to do here is we need to create basically a pool manager script that's going to hold our list of predefined bullets. So to get started with that, we're going to create an empty object and we're going to call this our pool manager. Now that we have a pool manager created, we can create a script that's going to manage our object pool. So let's create a new C# script. Let's call it pool manager and let's attach it to our pool manager. Open the script in Visual Studio. So here we are inside the pool manager, and let's take a look at what we need to do. Inside this pool manager, we need to know what object are we going to pre-instantiate. So here we can say what object to instantiate. So we need a game object variable that's going to store a reference to whatever object we want to instantiate. The next thing we need is a list of objects that we can use. So we're going to need a list of objects that can be used. So we're going to instantiate, say, 20 bullets, and then we're going to store those bullets inside of this list, and that's going to be the object pool list that we can use. If we have to expand it, we'll support that when we get to it. So all we have to do here is let's start filling this in. What object to instantiate? We have a bullet prefab. So before we get into supporting multiple objects, let's just focus on pooling one bullet. So here we're going to say public game object, and we're going to just create a bullet hole prefab. This is the object that we're going to instantiate several times and add to a list to be used. So bullet hole prefab. And then here we have a list of objects that can be used. This is going to use a list of game objects. So here, game objects, and then let's call this bullet hole list. So this is going to be our bullet hole list that we're actually pulling bullet holes from, and this is going to define what those bullet holes are. Let's save this script and head back to Unity. And on our pool manager, we should be able to now add in some bullet holes. So here you'll see here that we have a bullet hole prefab. I'm just going to add the bullet hole. And then here we have a bullet hole list. And this list is going to be dynamically generated. So we can predefine how many bullet holes we want to spawn. Now this gun probably shoots around 50 to 100 rounds per second, if I had to guess. So what we're going to do is we're going to probably instantiate maybe 50 bullets, and we'll see how we are with that. So let's create a variable to determine how many we'd like to instantiate. So here we can say public int, we'll say spawn count. And whatever that value is assigned to in the inspector is how many bullets we're going to pre-define and instantiate. Now to actually do that, we need to do that inside of our initialization method or during our loading. So it can be done in awake or void start. So inside of void start here, what's the logic? We need to spawn whatever the spawn count is, right? So if it's 50, we need to say spawn 50 bullets, add them to the bullet hole list. That's the logic here. Spawn 50 bullets, add them to the bullet hole list. So how do we spawn the bullets? We know we have to use the instantiate method. We can say instantiate, and then here we can say bullet hole prefab. And we know that this is actually going to instantiate the bullet holes. But now how do I instantiate 50 of them? Well, instead of typing out instantiate over and over again, we can use a for loop. So with a for loop, we can say, let's iterate through this 50 times and perform a task 50 times. So here we're going to say for int I equals 0, which is our index counter, while I is less than the spawn count. So if it's 50, we're going to cycle through 50 times and we're going to run some task. So while I is less than spawn count, after we instantiate, we need to say increment I, so that eventually I becomes greater than 50. So here we are going to say instantiate. This is going to be ran 50 times, and we want to basically just instantiate our bullet hole prefab. Now, this right here is going to work. I'm going to spawn 50 bullets just like this. The problem though is I now need to add the bullet that we spawn to this bullet hole list. In order to do that, we need a reference to the game object we instantiate. To do that, we need to store the game object that's created inside of a variable of type GameObject. So I'm going to create a local temp variable of type GameObject down here. So we're going to say GameObject, and we're going to say bullet equals the instantiate method. And that's going to assign the bullet we created to this reference variable right here. So I can actually change properties, the position, and so forth of that bullet that we spawned. The next thing I need to do here is I need to now take the bullet and add it to the bullet hole list. So let's access that list. So here we're going to say bullet hole list dot add, and we're going to add a game object. You'll see here in the parentheses, it's looking for a game object, and the game object we add is our bullet. So we spawn 50 bullets and we add each bullet to the list. Let's save this and we can head back into Unity. Now, as of Unity 2018, you no longer need to cast bullets or instantiated objects as game objects. However, it is still best practice to commonly cast them as a game object or whatever it is you're instantiating. So here, cast of a game object. Alternatively, you could say instantiate as a game object. And this is still true if you're using things like transform, or rigid body, for example, when you're instantiating. However, as of 2018.3, with the GameObject keyword, you no longer need to provide your cast, but I'll keep it in there for best practices. So here we have bullet equals instantiate bullet hole prefab as a game object, and then here we're adding that game object to our bullet hole list. Let's now run this, and let's see how this looks. So here we are. You'll see here that our spawn count is 0, so our bullet hole size list is going to be 0. Now let's change the spawn count to say 50. Let's run this. And you'll see here that inside of Unity, it created 50 bullets in the hierarchy, as well as check out our bullet hole list. This is our pool that we're now going to go through and use these values. Now, the next thing we need to do here is let's clean this up. I want these bullet holes to be a part of the pool manager, not just instantiate blindly in the hierarchy. To do that, we can modify the parent object and say equal to this object. So to do that, we add them to the list, and then here we can say bullet.transform.parent, and the parent is the transform of that object, and I'm going to say your parent is now this object that the script is attached to, which is our pool manager. So I'm going to say equals this.transform, which is whatever script or object this script is attached to. So by typing bullet.transform.parent, every bullet that is spawned is now going to be a child of the pool manager. So our spawn count is 50, and when we run it, you'll see now that our pool manager has 50 bullet holes. And you can further clean this up by adding an empty game object here for your bullets, and then using that as the parent object. We have our pool. The next thing that we need to do is actually turn off the object, because the goal here is that when we have 50 bullets in our scene, whichever ones are turned off, we're going to turn them on. So you can see here that our pool manager, they're all enabled, we need to actually disable them and then spawn them, or give the illusion of spawning them by enabling them at the position we need to. So after we initialize them and we add them to the list and set their parent, let's now turn them off. So here we're going to take the bullet and we're going to say .setActive, and we're going to set them to false. That is going to turn off the bullets. Let's save it and run it again. And you'll see here that our bullet hole are all turned off. Here's all the bullets and they're now off. What we can do now is we can cycle through this list and we're going to say, hey, is this bullet off? Then what we need to do now is turn it on. Now we're going to process the logic for actually creating these bullet holes. So we have our pool list, but what we need to do now is look back at our script where we instantiate bullet holes initially. Instead of instantiating bullet holes, what we now need to do is iterate through the bullet hole pool list. So we need to iterate through the bullet hole pool list, find an object that's, let's say, active equals false, and then what do we need to do with it? We need to set it to enable, and then change the position of the object. Position of the object matches the hitInfo.point, right? And then we also need to adjust rotation. So adjust rotation to surface normal. So we have the pseudocode and the logic. Let's now start it out. We're no longer going to instantiate the bullet holes. So I'm going to just comment this line out. Instead, we need to use our objects pool. The first thing we need to do here is we need to get a reference to our objects pool. So in order to do that, the best practice scenario is to turn this into a singleton. However, we don't have enough time for that, and you can check that out in the C# survival guide. But what we're going to do here is we're going to create a reference to the pool manager. So here at the very top, we're going to say private pool manager to create a handle to it. So here, private pool manager, and let's call this _pool. And then inside of void start, where we initialize things, we'll get a reference to the pool manager, where we'll assign the handle to that object. So here we're going to say _pool equals, I'm going to find the object. So GameObject.find. And alternatively, you can actually use GameObject.find object of type, and that's going to search through the entire hierarchy and find an object of type object pool or pool manager. And that's going to give us a reference to that script. Let's save this, and now we have access to our pool manager. Okay, so down here, what do we need to do? Well, we need to iterate through the bullet hole pool list. So how do we iterate through? We use a for loop. So here we're going to say for, and in here we say for int I equals 0. Well, I is less than what? What are we iterating through? Well, the pool's length. So here we're going to say pool.bulletHoleList.count. So while I is less than the count of however many bullets are in the pool, then we're going to increment I once we perform whatever task we need to. The next part here is to find an object that's active is equal to false in this list. So how do we do that? We need to now check if the current bullet we're looking at is set active to false. To do that, we can access the bullet by saying the pool.bulletHoleList, and then we want to access the current bullet we're looking at, which is done through the index of I. So that's the current bullet, and what I want to do now is I want to say if this bullet dot active in hierarchy, if it's active in hierarchy, we can't use it, but if it's not, we can. So I'm going to say here, if active in hierarchy is set to false. If that's the case, then we need to set it to enabled. So here we're going to say _pool.bulletHoleList sub I dot set active, and the answer is going to be true. So that bullet hole is now going to be true. Let's just run this and see what happens here. What's going to happen here is when I raycast, when we call that shoot method, it's going to iterate through our bullet holes and turn them all true. All right, so here we are in Unity, and you'll see here that if I start shooting, as soon as I shot, all of them become enabled. Now that's not what we want. Instead, we need to limit it to just one becoming enabled per shot. And as this method gets called, it will continue to cycle through. So after we set one of them true, we need to stop the operation. We just want to do one at a time. And that's where our break keyword comes into play. This is going to allow us to break out of the loop early and move on. So now we can go ahead and test this out. Let's save this. Let's hop back into Unity and let's add a break. So here is our pool. If I shoot, you'll see here that only a select few became enabled because of how many shots per second. If I shoot again, more become enabled. And that's the process of object pooling. What we need to do now is actually display them, but then also clean up and re-disable these previous holes. So we need to give them kind of like a lifespan. So here we're breaking them, and let's take a look at what's next to do. Here we set it to enable. Let's position the object at the hit info point. So now that we actually have the object pool created, before we break out of the loop, let's set the position at the hit point. So to access it, we can say pool. Let's access the current bullet we're on, which is our I index. And then here we're going to get the transform, and we're going to get the position. So transform.position. And we might want to get this in local space since it's a child object. So here we'll say transform.localPosition equals the hitInfo.point. And last but not least, we need to adjust the rotation. So here, once again, we'll say pool.bulletHoleList I, and then we need to access the rotation. So .transform.rotation equals the quaternion.lookRotation. And that's going to assign it to the hitInfo.normal. And that's going to adjust the rotation for us. Now, as an added challenge to you guys, tell me how we could clean this up to where I don't have to type out _pool.bulletHolesList I every single time. If you know the answer, show it off in the comments. So now that we have this, let's test it out. Head back into Unity, and let's see if we can spray our bullet holes. So you'll see here that I'm firing, and they're not showing up as intended. So let's see here, if we find this bullet hole, you'll see here that it is plastered, but it's plastered behind the wall for some reason. And that may be because I actually modified the local position, and I shouldn't have. We actually want the world position of those guys to be equal to the hit info position. So that was my mistake. Let's go back here. Let's rerun this, and we should have our object pool system working. Now here we are in our pool manager. Let's watch this in the hierarchy. And as I fire, we have bullet holes. Now what's gonna happen once I run out though? I'm out and there's no more bullet holes to spawn. So what we need to do is we need to set a lifespan for these bullet holes. We also need to create way more, but then also we need to support the ability to have more bullet holes if we need them. So to get started with this, let's first create a behavior for our bullet holes. I'm going to create a new C# script here, and let's call this bullet behavior. Now this bullet behavior, the only object or the only function this script is going to have is the ability to turn itself off after say 2 seconds of being displayed. So on our actual bullet prefab, we need to add this. In order to now add it to the prefab, we need to select the prefab, which is our bullet hole, and let's open the prefab up. In 2018.3, this is new. We need to open the prefab up, and then I can actually add our script to it, which is going to be our bullet behavior. Inside of our bullet behavior, all we're going to do here is we're just going to disable the object. We're not going to use update. And all we're going to do here is we're just going to turn off the object. So I'm going to turn void start into an IE numerator so that we can actually yield events within start. And here we're going to say yield return new, let's say wait for seconds, 2 seconds. So wait for seconds 2.0. And then we're actually going to want to use on enabled because start is only going to be called once, but we're going to reuse this object several times. So here we're actually going to do yield return new wait for seconds 2.0 f, and then let's change this to on enable. Now on enabled is called automatically by Unity before void start. It's whenever you turn off an object. If you turn it off, on disabled gets called. If you turn it on enable gets called. So when we enable this object, we're going to say wait 2 seconds, and then we're just going to turn it off. We're going to say this.transform.setActive or this.transform.gameObject.setActive off. We're just going to turn us off once we become enabled after 2 seconds. That's going to allow us to be recycled and go back into the pool because our pool is looking for disabled objects. So now that we have that behavior, let's run this. And we should see here in our pool manager that after 2 seconds, our first initial fires are going to get separated. Now you'll see here that on enable cannot be a coroutine. And so what that means is we just need to invoke a method here. So we'll call this void disable. And we'll set this back to void on enabled. And then we're just going to use an invoke method. So here we have an invoke, and you can specify the method to invoke, which is on disable, followed by a time frame, so 2.0 f. And then here we just need to use the proper thing, invoke. Okay, so that after 2 seconds, we're going to call this onDisable method, and the same logic applies. We're going to say this.transform.gameObject.setActive is false. We'll save it, head back into Unity. Let's run this again. And you'll see now that our bullet holes are going to actually recycle. So here inside of our pool manager, we have the first initial 5, and they turn off. And now we have an initial 5 again. We can constantly reuse these, and it's super optimal. The next task here is to dynamically extend this pool. So now that we have our bullet holes recycling, let's take a look at how we could expand it if we needed to. Inside of our pool manager, we have logic here that says for int I equals 0 while I is less than the spawn count, we're spawning all of them. Now inside of our look at mouse script is where we're actually doing all of the operations. Here is where we're checking if active in hierarchy equals false. Well, what happens if there is no active in hierarchy? So here, let's say here we iterated through the entire list, and if the pool is active, there's not a single one active, right? Let's say here that we got through the list and not a single one was active. What that means is that we need to now dynamically create a bullet hole, add it to the pool list, and allow it to be recycled in the future. We're going to use this if-else block here. We're going to say if we found something active in the hierarchy, fantastic. Else, we need to now check and do something. Now, what is that we need to check? We need to create a new bullet. However, we only want to create a new bullet only if we're on the last in the list. Only if we're on the last item of the list. We need to know that you cycled through the entire list and couldn't find any bullets to reuse. If that's the case, we'll create a new bullet, only if we're the last item on the list. So how do we check if we're the last item on the list? Well, it's our bullet count. So here, we can best check if it's the last item. We can say here, if _pool dot bullet hole, we can say here if on the bullet hole, the current bullet hole that we're on, if _pool dot bullet hole list, we'll say, and actually what's going to tell us if we're on the last one here is I. So here we can say if I, which is the indexer, is less than or equal to, I should say, if equal to, so if I is equal to our bullet hole list count, so here we're going to say our pool dot bullet hole list dot count, then what does that mean? Now, it's never going to, actually, I think it will actually eventually equal, and that's when it's going to get out of this for loop. And the problem with that is that it might not actually run. So I need to know if we're on the last one. So count is 50, however, numbers start at 0. While I is less than 50, it's going to run. If I equals 50, it's not going to run. So we need to actually subtract 1 from count so that it's 49. So if I is ever equal to the last one, then that means last bullet. And if we got into this else statement, that means that the last bullet was turned off. So what we need to do is now create a new bullet. So we need to actually instantiate the object. So we're going to create a game object. We're going to say new bullet. And we're going to set it equal to the information inside of our pool manager. So new bullet equals instantiate. We're going to instantiate the new bullets, which is the bullet prefab. So here we're going to access our bullet hole prefabs. And that bullet hole prefab is inside of the pool list. So here we need to say _pool dot bullet hole prefab. We're instantiating that guy. We're going to instantiate it as a game object. And now that we've instantiated it as a game object, we need to now come down here. We need to say new bullet dot set active is false. We need to parent the object as well. So not only are we turning the object off, but we now need to, before we do that, we need to set the parent. We need to say new bullet dot transform dot parent equals the pool parent. So _pool dot transform. And let's take a look at our pool manager. We also need to set the object to off, and we need to add it to the list. That's the most important part. So now that we've done that, let's add it to the bullet hole list. So here, set active false, we're going to say bullet hole prefabs list. So here we're going to access the pool dot bullet hole list, and we're going to add a new object to it, and that's going to be the new bullet. Okay. So that is how we dynamically create a bullet on the fly. And if we run this and test it out, everything should be okay. So let Unity compile. Let's check out the pool manager here. And let's check and see we'll be able to dynamically see the size of our list increase here. So we're at 50. And you'll see here as I fire, we're increasing our bullet count to 97, and we can't get past 97 because we're recycling old bullets. So at most in my game, I'll only ever create 97 bullets and recycle. Thanks to all of our awesome Plus and professional members. You guys are the reason we create this amazing content every week for you. And special thanks to LariDK, 6, Lucky Ducky 10, and OJ Zach. You guys rock.